Problem number 2, under notes. We just got a brief start during the last class, but it's the liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, and 90 units of vitamin C daily. A cup of dietary drink X provides 60 calories, 12 units of vitamin A, and 10 units of vitamin C. A cup of dietary drink Y provides 60 calories, 6 units of vitamin A, and 30 units of vitamin C. And suppose that dietary drink X costs 12 cents per cup, and dietary drink Y costs 15 cents per cup. And what we did yesterday is we said, well, drink X is going to be represented by the variable X, and drink Y is going to be represented by the variable Y. And we also put in the money down here, write a function for the total cost of dietary drink X and Y. And I'm actually going to scoot that down a little bit. Oh my. And now what we need to do is we need to come up with our inequalities here in part B to describe the minimum daily requirements of calories and vitamins from these two drinks. And before I get going too far in this problem, I need to star this here because it's at least 300 calories. And what that means is it has to be 300 calories, but it can be more. And what we're looking for when we solve this is we want to find the minimum daily requirements. So we're looking for the smallest number this time instead of making the most profit. And when we start these problems, we need to assume that we're going to be working with drink X. We're going to have some drink X, and we're also going to have some drink Y. So it doesn't have to be the first two that you write down, but it might be helpful. But in this particular problem too, there's actually 3 things that are happening in the problem. And the first one, the first inequality that we're going to write, if I can spell calories and calories correctly, C-A-L-O-R-I-E-S, I was on the right direction. We're going to have an inequality that has calories in it. So we look up here at the first bullet, and it says a dietary drink X provides 60 calories. So 60 X. And a dietary drink Y provides 60 calories as well. But remember this time, we need to have at least 300 calories. We can have more. So in this particular problem, this is going to be greater than or equal to. Every problem that we've done up until now has always been less than or equal to. And in fact, most of the problems that we work on are going to be less than or equal to. But we're not limited to less than or equal to. So I want to show you this, greater than or equal to. And I'm going to leave some space here because we're going to have to eventually put this into slope-intercept form. So the next inequality that we're going to write is going to have to deal with vitamin A. And when we look back here at vitamin A, in our first bullet point, it says a cup of dietary drink provides 12 units of vitamin A. So this is going to be 12x. And how much vitamin A comes from our other dietary drink, Y? Well, we only get 6 vitamins, 6, I don't know if it says 6 units. And again, we're looking at least. We need to have at least that many, but we need to have, for vitamin A, way back at the top of our paper, if I can get back up there, it says we have to have at least 36 units of vitamin A. So greater than or equal to 36. And then I'm going to come off to the side here, because I'm going to have to put this in slope-intercept form. We've got one more inequality, which is going to be the vitamin C inequality. And if we look back at our first bullet, for dietary drink X, we have 10 units of vitamin C. And for our drink Y, we have 30 units. And we can't have anything less than, well, looking up at the very top of our equation, 90 units of vitamin C. So there's our three inequalities that we're going to graph. In fact, we're really graphing 5, because once again, we need to assume that we're going to have some dietary drink X, we're going to have some dietary drink Y, which are the first two inequalities we wrote down. And that means we're going to have this line here and that line there. Again, I apologize for not using a ruler. But X is greater than or equal to 0. We have to cross the X-axis. That's going to be a vertical. And Y is greater than or equal to 0. It has to cross the Y. That's going to be a horizontal. And if you're struggling with that, you should write that down on your paper. And now we're going to deal with the rest of our inequalities that we need to put in slope-intercept form. That means we need to solve for Y. So we're going to subtract 60x from both sides. And we end up with 60y is greater than or equal to negative 60x plus 300. We're trying to solve for y. So we're going to divide by 60. We get y is greater than or equal to negative x plus 5. What's our y-intercept of this line? And hopefully you're thinking 5. Our slope, this is the one that seems to be causing a little bit more trouble. Remember, it has a number of 1 in front of it. In fact, it's negative 1. Our slope is negative 1 over 1 because slope is defined as rise over run. So when we go over here to graph that, here's 5. Down 1 to the right 1. 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 And if you didn't get a ruler today, then borrow one from somebody around you. And we're going to go through that process again with our green inequality for the vitamin A. We need to put this into slope-intercept form. We're going to subtract 12x from both sides. And we get 6. Y is greater than or equal to negative 12x plus 36. Divide both sides by 6. And when we do, we get y is greater than or equal to negative 2x plus 6. And once we get it in slope-intercept form, we need to identify what's the slope and what's the y-intercept. In fact, we usually start with the y-intercept, which is 6. It's the constant. It's the value that doesn't have a letter with it. And our slope is negative 2 over 1 because slope is defined as rise over run. Would be equal to 6. And we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And we get there. We have to go through that process one more time with our vitamin C inequality. We're going to solve for y. Subtracting 10x from both sides. And we get 30. Y is greater than or equal to negative 10x plus 90. 30 times y, we're going to divide everything by 30. And we end up with y is greater than or equal to negative 1/3 x, because 10 over 30 reduces, plus 3. And our slope is negative 1/3. Our y-intercept is 3. So we're going to graph that. So it's 3. And then it's down 1 to the right 3. Down 1 to the right 3. Down 1 to the right 3. But be careful with the shading. Because if you're working ahead of me, this one's a little bit different from some of our other problems. When we start here, with our x is greater than or equal to 0, our y is greater than or equal to 0, and by the way, you might want to wait to shade until I have it in there, because it's going to jumble up the picture a little bit. But x is greater than or equal to 0, we're either going to shade to the right or to the left, and we really can only shade to the right. And it makes sense because we want to have positive drinks. And the same thing with the horizontal. We're either going to shade above or below the line, but we need to have positive values. And I'm only going to do one of them for time purposes. But the other three, when we shade here, what we do is we pick the value, oftentimes 0, 0, that is not on the graph. And I'm going to try to squeeze it in here. 60 times 0 plus 60 times 0, is that greater than or equal to 360? No. We don't shade to this side of the line. We shade to this side of the line. And time permitting, I would do that for the green and for the orange line. But what happens is, when we actually find where all of the shading intersects, we end up shading in this area. Oh! Just trying to slide this around. So roughly there's our picture. Let me scoot it so that we can see it. A little bit better. There's where we shade on this one. And in terms then of finding our points, and actually before I talk about the points, this is called an unbounded region. It's not a convex polygonal region. It's an unbounded region. And we actually have 5 vertices that we're going to use down here in our next portion of our problem, which say list the coordinates of the feasible region. It's going to be this point here, this point here, this point here, this point here, and this point there. The points where different inequalities intersect. So when we fill that in, again, you don't have to have the same order, but you need to have all 5 of them. The first one that I just graphed was 0, 6. We went over 0, up 6. The second one is 1, 4. We have 3, 2. We have 6, 1. And we have 9, 0. I'm going to put those values back into the function there in part E that we came up with in the last class. So our functions f of x and y equals 0.12x plus 0.15y. And the first value that we're going to put back in there is 0.6. So 0 is going to go back in for x, and 6 is going to go back in for y. And when we type that in our calculator, we get 0.9. If you prefer 0.90. Our next point is 1/4. 1 is going to go back into our equation for x, and 4 is going to go back in here for y. Typing it in gives us 0.72. Our next value. We get 0.12 times 3 plus 0.15 times 2, and we type it in. Gives us 0.66. Next value is 6/1. Six is going to go back in for x, and 1 is going to go back in here for y. And when we type it in, we get 0.87. And finally, our last point, which is 90. And we get 0.12 times 9 plus 0.15 times 0. 9 going back in for the x, 0 going back in for the y. And we get 1.08. Well, look at what the question is asking now here to come up finally with our answer. Determine how many cups of each drink must be consumed to minimize the cost. What this means is, if we drink all of drink Y in this first inequality, or first equation, that's going to cost us 90 cents. But what we're looking for here is the smallest value, which happens to be in green in this case. 66 cents is going to be our minimum value. So when we answer this question here, we're going to drink 3 cups or 3 drinks of X and 2 drinks of Y. And that's going to cost us 66 cents.